What if we could trace the very origins of life itself? Why does the cosmos appear so perfectly tuned? Is the universe hiding its creator? Could the universe itself be alive? Is life a cosmic accident, or is it a destined event? Are we truly alone in the universe? These questions have fascinated thinkers, scientists, and philosophers for centuries, expanding the limits of human imagination. The mystery of how life began is one of humanity's most profound inquiries. Despite centuries of progress in science and technology, the origins of life remain shrouded in uncertainty, leaving us to speculate at the intersection of science, philosophy, and even metaphysics. From the chaotic dance of atoms billions of years ago to the emergence of complex sentient beings, the journey of life has sparked debates across disciplines. Is our existence the result of sheer chance, inevitable under universal laws, or the product of higher intentional design? Each perspective offers a unique lens, but none can yet claim to have the definitive answer. This exploration will delve into three primary perspectives: the hypothesis that life arose by coincidence, the argument that life was an inevitable outcome of nature's laws, and the possibility that a higher consciousness designed the conditions for life to emerge. Through these lenses, we will uncover the profound implications of each theory, examining evidence, raising questions, and contemplating what it all means for our understanding of existence. The coincidence hypothesis suggests that life is a fortunate accident, a consequence of countless random interactions occurring under the right conditions. Imagine a chaotic primordial Earth, its surface bombarded by meteors, its atmosphere thick with gases, and its oceans bubbling with chemicals. In this seemingly anarchic environment, molecules collided, bonded, and eventually formed the building blocks of life. This hypothesis proposes that life is not guaranteed, but rather the result of a miraculous convergence of circumstances. It argues that, given the vastness of time and space, such a cosmic accident was bound to occur somewhere, with Earth being the lucky winner in the lottery of existence. Abiogenesis, the scientific explanation for life's origins, suggests that life arose naturally from non-living chemical compounds. This theory gained attention with the famous Miller experiment in 1953, which simulated early Earth's conditions by exposing a mixture of water, methane, ammonia, and hydrogen to electric sparks. The experiment produced amino acids, organic compounds essential for life, demonstrating that complex molecules could form spontaneously under the right conditions. Subsequent research has expanded on these findings, identifying potential pathways for simple molecules to organize into self-replicating systems, the precursors to life. However, abiogenesis faces significant challenges, as critics argue that forming life's essential components, such as proteins or RNA, is far more complex than producing amino acids. Even under ideal conditions, the probability of assembling functional proteins by chance is astronomically low, leading skeptics to question whether randomness alone could account for the emergence of life. Let's consider the staggering odds involved in life's emergence. The chance of a single functional protein forming spontaneously has been compared to a monkey randomly typing out Shakespeare's Hamlet by hitting keys on a keyboard. Now multiply that improbability by the complexity of an entire living cell. Scientists estimate that Earth existed for approximately 1 billion years before life emerged. While this time frame provided countless opportunities for chemical interactions, it also underscores how rare and extraordinary the conditions must have been for life to begin. The coincidence hypothesis raises a critical question. If life is such a rare accident, why does the universe appear so finely tuned to allow it? For instance, Earth orbits within the Goldilocks zone, where temperatures are just right for liquid water, a key ingredient for life. Some argue that this perfect alignment is too precise to be purely coincidental, while others counter that the vastness of the universe ensures that some planets would inevitably meet these conditions. To understand this perspective, think of the universe as a vast casino and Earth's origins as a game of roulette. The odds of life forming may have been infinitesimally small, but the wheel spun countless times across the cosmos, and Earth was the one lucky spin where the ball landed perfectly. The hypothesis that life arose by coincidence presents a picture of a fragile, improbable event within the vast chaos of the universe. Yet, this perspective also leaves us with a profound sense of uncertainty. If life truly is a cosmic accident, what does that say about its meaning, or lack thereof? In contrast, the necessity hypothesis argues that life was an inevitable outcome. Unlike the randomness of the coincidence perspective, this view suggests that life was bound to happen. It posits that the physical and chemical laws governing the universe made life's emergence unavoidable. The emergence of life, in this perspective, is not a miraculous anomaly, but rather a natural outcome of the universe's design. When conditions align, life becomes an inherent expression of the universe's potential. Imagine the universe as a finely tuned orchestra, with each instrument, from gravity to electromagnetism, playing a vital role in creating the conditions that make life not just possible, but inevitable. Life's building blocks depend on universal principles that drive molecules to organize into more complex forms. For example, Earth's position in the Goldilocks zone, where it orbits the sun at just the right distance, allows liquid water to exist, a key factor for life. Other planets in the universe may share similar conditions, suggesting that life could arise wherever these favorable circumstances are met. Additionally, certain molecules have an innate tendency to self-organize, such as phospholipids forming membranes in water, resembling the cell walls of living organisms. This self-assembly hints that life's essential structures could naturally emerge under the right conditions. This view is supported by the discovery of extremophils, organisms that thrive in extreme environments, from deep-sea hydrothermal vents to boiling acid springs. These resilient creatures show life's remarkable ability to emerge and survive in conditions once thought uninhabitable, reinforcing the idea that life could arise wherever conditions are right. The theory suggests that specific chemical reactions under particular conditions could inevitably lead to life. For instance, amino acids tend to link together under certain environmental pressures, potentially forming proteins over time. Water's unique properties, such as its ability to dissolve various substances, make it a crucial solvent for biochemical reactions, while carbon's versatility allows it to form complex molecules like DNA and proteins, which are the backbone of all known life. Recent discoveries of organic compounds on comets and meteorites suggest that the building blocks of life are not unique to Earth. These findings support the notion that life's raw materials are widespread throughout the universe, increasing the likelihood of life's emergence elsewhere. Furthermore, extremophils challenge the idea that life requires Earth-like conditions. Organisms such as tardigrades can survive in the vacuum of space, extreme radiation, and intense heat, showing that life might emerge in environments we once deemed uninhabitable. The discovery of thousands of potentially habitable exoplanets further supports the idea that life could exist beyond Earth. Many of these planets orbit stars similar to our Sun, within their own Goldilocks zones. If these planets harbor life, it would strengthen the view that life is a universal phenomenon rather than a unique accident. However, if life is indeed inevitable, why haven't we found definitive evidence of it beyond Earth? This paradox, known as the Fermi paradox, challenges the necessity hypothesis. Are we simply looking in the wrong places, or is the emergence of life far rarer than we assume? The silence of the cosmos raises as many questions as it answers. Consider life as a seed planted in fertile soil. The right conditions, sunlight, water, nutrients, make growth inevitable. In a similar way, when the universe provides the right conditions, life, like a seed, is destined to flourish. The necessity hypothesis suggests that life is an intrinsic part of the universe, woven into its very fabric. This perspective shifts the narrative from randomness to inevitability, implying that wherever the universe creates the right conditions, life will arise. The design hypothesis proposes a different perspective. What if life's emergence was not a product of random chance or inevitable natural laws, but a deliberate act of creation? According to this view, the complexity of life and the universe's apparent fine-tuning point to the influence of a higher intelligence, a consciousness that set the stage for life to emerge. Imagine finding a watch on a beach. Its intricate gears and precise design are unlikely to have come about by accident. Similarly, proponents of the design hypothesis argue that life's complexity, from DNA's coded instructions to the universe's finely tuned physical constants, suggests purposeful design rather than random chance or inevitability. The idea of a higher consciousness shaping life has deep roots in philosophy and spiritual traditions. Many creation stories from various cultures, such as the Genesis narrative in the Bible, Brahma's creation in Hinduism, or the dream time of Aboriginal Australians, portray life as the intentional work of a divine being or higher force. Ancient philosophers, including Plato and Aristotle, posited the existence of a prime mover or intelligent designer who initiated the cosmos. These philosophical ideas resonate with the design hypothesis, reflecting humanity's long-standing intuition that life and the universe may hold deeper meaning and purpose. The fine-tuning of the universe, seen in physical constants such as the strength of gravity, the charge of the electron, or the cosmological constant, is so precisely balanced that even the slightest deviation in these values would prevent life as we know it. The precise fine-tuning of physical constants, such as the strength of gravity, has profound implications for the existence of life. If gravity were even slightly stronger or weaker, stars would not form or sustain nuclear fusion, which is essential for the creation of planets and life. The fine-tuning argument suggests that these precise values are unlikely to have arisen by chance, and may instead point to intentional calibration by a higher intelligence. DNA, often referred to as the blueprint of life, is a molecular code that governs the development and functioning of all living organisms. Its complexity and specificity have led some scientists and philosophers to compare it to a computer program. This raises the question, could such intricate programming have arisen without an intelligent programmer? Some biological systems, like the bacterial flagellum or the human eye, are so complex that they appear irreducible, meaning that they could not function if even a single part were removed. Proponents of this view argue that such systems challenge the gradual explanations offered by evolutionary theory, suggesting that a designer's hand might be involved. However, the design hypothesis has faced significant criticism. Critics argue that intelligent design is anthropocentric, projecting human concepts of purpose and complexity onto the universe. Furthermore, unlike scientific theories that can be tested and falsified, intelligent design often relies on inference, which some consider unscientific. Alternative explanations such as evolution and natural selection provide robust mechanisms for explaining life's complexity, diminishing the need for a designer. In recent years, some scientists have attempted to reconcile the idea of design with empirical evidence. One such concept is simulation theory, which proposes that our universe is a simulation created by an advanced intelligence. Proponents, like physicist Nick Bostrom, argue that if future civilizations develop the technology to simulate universes, it's statistically likely that we are living in one. Another concept, panpsychism, suggests that consciousness is a fundamental property of the universe, present in all matter. In this framework, the universe's design could emerge from a collective consciousness rather than an external creator. To better understand the design hypothesis, imagine life as a symphony. The universe is the orchestra, and its laws are the instruments. A symphony requires a conductor to arrange the notes into harmony, just as life's emergence may require a designer to orchestrate the right conditions for it to arise. Despite their differences, the three perspectives, coincidence, necessity, and design, share common ground in addressing the profound mystery of life's origins. All three recognize that life is extraordinary, whether it emerged by accident, inevitability, or design. Each perspective underscores the rare and complex nature of living systems in a vast, seemingly indifferent universe. The interplay between chaos and order is another shared theme. The coincidence hypothesis emphasizes the randomness of molecular interactions, while the necessity hypothesis shows how order emerges naturally from the laws of physics and chemistry. The design hypothesis, on the other hand, stresses intentional order, suggesting that chaos is merely the backdrop for a purposeful plan. Each of these approaches also acknowledges the role of universal laws. Whether these laws create life by chance, inevitability, or design, they are fundamental to the discussion. However, the underlying assumptions of each perspective often lead to sharp contrasts. The coincidence hypothesis relies on randomness, viewing life as the result of improbable events, while the necessity hypothesis emphasizes determinism, positing that life is a predictable outcome of universal principles. The design hypothesis introduces the idea of a higher intelligence or purpose, while coincidence and necessity remain rooted in natural processes, rejecting the need for external intervention. The philosophical implications of these perspectives are profound. Coincidence suggests that life has no intrinsic meaning, as it is a random occurrence. Necessity offers a middle ground, implying that life has significance as a natural product of the universe. The design hypothesis infuses life with purpose, proposing that it is part of a deliberate cosmic plan. Some thinkers argue that these perspectives are not mutually exclusive, but could represent different layers of the same reality. Life's origins could involve a combination of random events and deterministic laws. For instance, the formation of essential molecules might be random, but their assembly into complex systems could follow inevitable patterns designed through natural processes. Moreover, the design hypothesis doesn't necessarily conflict with science. A higher intelligence might have created the universe's laws in such a way that life emerges naturally, with occasional elements of randomness shaping its path. To visualize how these perspectives might coexist, imagine a painter creating a masterpiece. In the case of coincidence, the paint splatters randomly on the canvas, forming an unplanned image. With necessity, the painter uses precise strokes, guided by the properties of the brush and paint, ensuring that the painting logically emerges from the tools. In the design view, the painter has a vision from the start. intentionally guiding every element of the painting toward a final purpose. Perhaps life's origins resemble a collaboration between these approaches, a dynamic interplay of chaos, inevitability, and vision. The origins of life remain one of humanity's greatest mysteries, inspiring theories that range from randomness and inevitability to intentional design. The coincidence perspective emphasizes life's fragility, viewing it as a miraculous anomaly in a chaotic universe. In contrast, the necessity perspective elevates life to a fundamental feature of the cosmos, suggesting that it is the result of inherent laws and principles. The design view introduces purpose, proposing that life may be the deliberate creation of a higher intelligence. Each perspective provides a compelling lens, but none alone can fully explain the profound complexity and meaning of life's emergence. As we explore these ideas, one question arises: must we choose just one perspective? Perhaps life's origins encompass all three viewpoints in a complex interplay. Coincidence might explain the unpredictable initial conditions that led to life, while necessity could describe the universal laws that guided its development. Design could reflect an underlying purpose woven into the fabric of the cosmos. Much like a mosaic, the full picture of life's origins might only emerge when we consider these perspectives together, embracing their unique insights and shared mysteries. The exploration of life's origins ultimately leaves us with more questions than answers. If life is a cosmic accident, how do we make sense of its meaning, or lack thereof? If life is inevitable, what responsibilities do we have as part of the universe's natural progression? If life is designed, what role might humanity play in a grander plan? As we contemplate these questions, we are reminded that the journey to understand life's origins is as important as the answers themselves. Gazing into the night sky and marveling at its vastness and mystery, one truth becomes clear. Our existence is an extraordinary phenomenon. Whether born of chance, necessity, or design, it is up to us to make meaning from this knowledge, to explore with curiosity, and to live with purpose. For in the grand tapestry of the universe, we are both its observers and participants, a fleeting yet vital spark in the eternal story of existence. Is the universe simply a vast, lifeless expanse? Or is there something more? Something conscious, alive, or perhaps even self-aware? Could the cosmos be more than a collection of stars and galaxies scattered across empty space? What if we are all part of a larger mind, an immense cosmic brain, where each galaxy is like a neuron, working in concert with others? Is it possible that consciousness did not emerge randomly, but was an intrinsic part of the universe from the very beginning? Could our thoughts, emotions, and experiences be tiny reflections of the universe's own awareness? If the universe is indeed conscious, then what role do we play in it? Are we merely observers, or are we active participants helping the cosmos understand itself? Why do the laws of physics seem so perfectly tuned for life? Could it be that the universe chose conditions that allow consciousness to flourish? And if so, is there a purpose to this grand design? As we look up at the stars, are we witnessing the universe looking back at itself through us? If everything is connected, where does individuality end and universality begin? Do our minds hold the keys to unlocking the universe's mysteries, or are we simply parts of a complex universal mind that has yet to fully comprehend itself? Let us delve into these questions and explore the possibility that the universe might not only contain consciousness, but could in fact be consciousness itself, pondering its own existence through each of us. The cosmic brain hypothesis. In the vastness of the cosmos, where galaxies stretch like points in an endless web, scientists and philosophers have noticed a curious pattern of resemblance between the structure of the universe and that of the human brain. The universe, composed of billions of galaxies, appears to be connected in ways that resemble the neural networks within our own minds. This similarity has prompted the provocative question: could the universe itself function as a kind of brain? When we observe the intricate arrangement of galaxies, clusters, and superclusters in the cosmic web, we see something far from random. Just as neurons in the brain connect through a complex network of axons and synapses, galaxies form connections through vast filaments and dark matter. Astrophysicist Franco Vasa and neuroscientist Alberto Folletti conducted a study comparing the structures of the cosmic web and the human brain's connectome, finding striking parallels between the two. Their research showed that while these structures operate on vastly different scales, the patterns and connections share a deep structural similarity. For instance, both the brain and the universe exhibit complex networks that follow similar organizational rules, with small, dense nodes connected by long branching filaments. In the brain, These nodes are neurons. In the universe, they are galaxies or galaxy clusters. This resemblance has led to the hypothesis that the universe may function as a colossal brain. In our brains, neurons communicate through electrical signals, building networks that enable complex thought, emotion, and consciousness. The universe, too, has its form of communication through gravitational forces, electromagnetic radiation, and possibly even dark matter. But the question remains, does this cosmic network actually process information? The idea that the universe could be conscious is supported by various theories, including panpsychism, which suggests that consciousness is a fundamental quality embedded in all matter. According to this view, even the smallest particles that make up galaxies could possess some form of proto-consciousness, akin to the rudimentary awareness seen in simpler organisms. This doesn't mean that rocks or stars are aware in the same way humans are, but rather that they might contain a basic form of consciousness. When combined across the vast networks of the universe, this could potentially lead to a larger, unified awareness. Another perspective on universal consciousness is the integrated information theory, IIT. Developed by neuroscientist Giulio Tononi, IIT posits that consciousness arises from the degree to which a system can integrate information. In the human brain, this integration happens among billions of interconnected neurons. If we apply IIT to the universe, we could argue that the structure of the cosmic web, with its vast networks of galaxies, might allow for a similar kind of information integration, possibly giving rise to a form of universal consciousness. Although this hypothesis remains speculative, it opens the intriguing possibility that the universe, with its vast array of galaxies and matter, might not just process information, but might also experience a rudimentary form of awareness. However, while the brain and the universe share certain structural similarities, they operate on vastly different scales and with different types of connections. Neurons communicate through electrochemical signals, while galaxies and clusters interact primarily via gravitational forces. Unlike the rapid, continuous flow of signals in our brains, interactions across the cosmos are slower, constrained by the speed of light and the immense distances involved. Despite these differences, some scientists speculate that black holes, which reside at the centers of galaxies, could serve as focal points in a cosmic communication network. With their immense gravitational pull, black holes might function similarly to neural hubs in the brain, potentially playing a key role in the universe's information processing. One potential link between brain activity and cosmic activity comes from quantum mechanics. At the quantum level, particles can exhibit entanglement, where two particles remain connected across vast distances, responding instantaneously to each other's states. Some researchers suggest that this phenomenon, known as quantum entanglement, could represent a form of non-local connectivity that may be essential for a universal consciousness. If such connections exist on a cosmic scale, they could facilitate a kind of communication that transcends traditional physical limitations, similar to how neurons in the brain maintain a cohesive consciousness, despite being physically separate. The holographic principle is another theory supporting the cosmic brain hypothesis. This idea suggests that all the information in the universe might be encoded on a two-dimensional surface, much like a hologram. If this is true, our experience of a three-dimensional universe could simply be a projection of this information. In this sense, the entire universe might be processing information in a way similar to a brain, creating the complex reality we observe. Some scientists believe that this principle could help unify quantum mechanics and general relativity, implying that our reality is fundamentally informational, with consciousness potentially woven into its very fabric. Philosophical roots: Schrödinger and the unified mind. The concept of a conscious universe, though it may seem modern, has philosophical roots that stretch back centuries. One of the most intriguing figures to explore these questions was Erwin Schrödinger, a Nobel Prize-winning physicist whose work extended beyond quantum mechanics. Schrödinger believed that consciousness is not simply an individual phenomenon confined to the human brain, but could reflect a universal singular mind. His views were influenced by Eastern philosophy, particularly the concept of Atman equals Brahman from Indian Vedantic thought. In simple terms, this idea suggests that the self is ultimately indistinguishable from the cosmos or universal reality. Schrödinger regarded this not as a poetic concept, but as a serious philosophical framework that questioned the division between individual minds. Could it be that what we perceive as separate minds are in fact facets of a single unified consciousness? Schrödinger's belief in a shared mind arose from a fundamental question: why is consciousness always experienced as singular? Throughout his career, he observed that no one ever experiences more than one stream of consciousness at a time. This led him to wonder if individual minds might only appear separate due to physical limitations and perception, while in reality, they are connected by an underlying universal mind. The idea of a unified consciousness also addresses an age-old philosophical dilemma: the nature of reality itself. Schrödinger argued that metaphysics, the study of what truly exists beyond our physical world, is not a byproduct of physics, but a foundation that precedes it. In his view, our inability to empirically prove the existence of an external world, independent of our minds, or separate individual consciousnesses, is precisely what hints at a singular, interconnected reality. Indeed, all could be part of one universal consciousness, which might explain why mind and matter appear intertwined in ways that science has yet to fully comprehend. Schrödinger often used the metaphor of a crystal to illustrate his concept. Imagine a crystal exposed to light, refracting it into many distinct colors. Each color represents individual conscious minds, while the crystal itself symbolizes the singular, cosmic consciousness that underlies them all. Even though we perceive ourselves as unique individuals, from this perspective, we are merely different expressions of the same essential consciousness, refracted through various physical forms. At the time, Schrödinger's ideas were not widely accepted in Western scientific circles. However, his concept of a singular mind has continued to influence both science and philosophy, inspiring researchers to explore consciousness beyond the confines of the individual brain. By proposing that individuality might be an illusion, Schrödinger opened the door to a profound shift in our understanding of consciousness. If the self is indeed an illusion, then we could be part of a collective experience far more expansive than personal identity would allow. Schrödinger's perspective also delves into the relationship between mind and matter. He argued that matter, as we understand it, is an objectification of the unified mind, a way for consciousness to experience the universe through tangible forms and sensations. This framework led him to entertain the possibility that physical reality might be a simplified projection of a more complex, non-physical realm. In this model, the physical world appears separate and independent because it serves as an interface, a simplified map of reality, allowing conscious beings to interact with it. Scientific possibilities, conscious agents theory. While Schrödinger's concept of a unified mind may sound abstract, modern science has begun to develop theories that bridge these philosophical ideas with empirical research. One such theory is the conscious agents theory, CAT, which explores the idea that consciousness is a fundamental property arising from interactions within complex systems. This theory suggests that consciousness is not exclusive to humans or biological organisms, but can emerge anywhere. There is enough complexity and connectivity, potentially even on a cosmic scale. According to Integrated Information Theory, IIT, consciousness in a system can be measured by a metric called phi, which represents the system's capacity to integrate information. If a highly interconnected system, like the universe, has a high enough phi, it could exhibit characteristics of consciousness. While applying IIT directly to the cosmos remains speculative, it suggests that consciousness may not be confined to biological brains, but could be a fundamental characteristic of any sufficiently complex system, from individual organisms to the universe as a whole. Conscious agents, theory and universal consciousness. Beyond IIT, conscious agents theory, introduced by cognitive scientist Donald Hoffman, presents another fascinating approach to universal consciousness. CAT proposes that consciousness is the fundamental building block of reality, and that all physical entities are representations or interactions of these conscious agents. In this view, conscious agents do not emerge from physical matter. Instead, they are primary, and physical reality arises from their interactions. This idea aligns with Schrödinger's notion of a unified consciousness, as it suggests that every part of reality, from subatomic particles to galaxies, is interconnected through a web of conscious experiences. CAT posits that the universe is essentially a network of interacting conscious agents, and each interaction produces a different aspect of the observable world. Just as neurons in the brain interact to create our experience of consciousness, conscious agents in the universe could interact to generate a form of universal consciousness. In this model, what we perceive as physical reality is merely an interface that allows conscious agents to interact within a shared, structured environment. In other words, reality as we know it could be the product of these conscious interactions, with physical matter and energy being byproducts. Challenges and implications. While these theories are groundbreaking, they also face considerable challenges in terms of empirical testing and philosophical implications. Measuring consciousness in non-human systems, let alone on a cosmic scale, remains a daunting task. Currently, IIT has been primarily applied to biological brains, where we can observe and measure information flow among neurons. Applying IIT to the universe would require a way to quantify information integration among galaxies, or other large-scale structures, a feat beyond our current scientific capabilities. Nonetheless, both conscious agents theory and integrated information theory put push the boundaries of our understanding, suggesting that consciousness might not be a unique product of evolution on Earth. Instead, consciousness could be a fundamental aspect of reality itself, arising from any sufficiently complex network. If this is true, it would imply that our universe, with its vast network of galaxies and intergalactic connections, might indeed possess some form of awareness. These theories not only propose a radically new perspective on consciousness, but also hint at a profound interconnectedness underlying all things in a conscious universe, where every action and interaction contributes to this larger awareness. In a broader context, this suggests that galaxies, stars, and even inanimate matter could play a role in the expansive tapestry of consciousness. If the universe is indeed a conscious system, our existence within it becomes part of a much larger story, one where each of us may contribute to the universe's journey towards self-awareness. Testing the hypothesis: is the universe self-aware? The idea that the universe might be conscious raises an intriguing challenge. Can we test this hypothesis? Scientific theories are most valuable when they can be empirically tested, and while proving universal consciousness is difficult, researchers are developing methods that may bring us closer to an answer. One such method involves quantum entanglement, a phenomenon where two or more particles become linked, their states remaining interconnected regardless of physical distance. Some researchers suggest that these quantum connections could extend on a cosmic scale, potentially creating a kind of communication across the universe. This would mirror the interconnectedness of a conscious mind. If entanglement exists on a cosmic level, it could provide a mechanism for a unified awareness, enabling instant connectivity across vast distances, much like how neurons communicate within the brain. Another approach involves studying large-scale cosmic structures and searching for patterns or anomalies. If the universe were conscious, we might expect to observe signs of self-organization or purposeful structure beyond what randomness alone can produce. For example, researchers are investigating phenomena like dark matter and dark energy, which constitute the majority of the universe, but remain largely unexplained. Studying these mysterious components could potentially reveal new insights into the universe's workings and hint at an underlying consciousness. A particularly radical approach looks at how we, as conscious beings, interact with the universe. Some interpretations of quantum mechanics, such as the Neumann-Wigner interpretation, propose that consciousness directly influences physical reality, as seen in the observer effect, where particles behave differently when observed. If our consciousness can indeed affect the physical universe at a quantum level, this could suggest a deep connection between individual minds and universal consciousness. Researchers could design experiments to explore whether conscious observation has measurable effects on large-scale quantum phenomena, potentially revealing a relationship between human awareness and universal processes. While none of these methods can definitively prove universal consciousness, they each offer incremental steps toward understanding the role consciousness may play in the universe. By pushing the boundaries of physics and cosmology, scientists are developing a framework that could one day provide evidence for or against the cosmic consciousness hypothesis. These experimental approaches, though speculative, encourage us to think beyond traditional boundaries. While measuring universal consciousness remains a distant goal, these early steps invite us to reconsider the potential of scientific inquiry. The evolution of cosmic consciousness. Could consciousness itself evolve alongside the universe's grand narrative? If the universe harbors some form of awareness, it might not have always existed in its current state. Much like stars, which are born, shine, and eventually fade, consciousness may evolve, deepening in complexity and expanding in scope over cosmic eons. Imagine consciousness as a seed, planted at the inception of the universe at the moment of the Big Bang. In its earliest moments, it might have been a mere whisper, a faint awareness of being. As the universe expanded and galaxies and stars formed, this nascent awareness could have grown, stretching and evolving in tandem with the formation of these astronomical structures. In this vision, consciousness is not static. It evolves with the universe, shaped by the same forces that govern the stars and planets, flowing and adapting as the cosmos unfolds. Perhaps in the early universe, consciousness was primitive and formless, much like the first simple cells on Earth. But as matter formed into increasingly complex systems, stars, galaxies, and clusters, cosmic consciousness may have taken on more intricate patterns, becoming more refined over time. As galaxies cluster together, connected by dark matter, they might function like neurons in a vast cosmic brain, weaving a growing web of awareness. Could it be that, with each passing epoch, this consciousness refines itself, evolving toward a more sophisticated form of self-awareness? As the universe evolves, does it, like a growing child, develop new layers of complexity? Could it, in its immense age, come to possess something akin to wisdom, an awareness shaped by countless cosmic experiences over eons? This idea sparks further curiosity. If consciousness evolves along with the universe, is there a point where it becomes fully aware of itself? Perhaps in its primordial state, consciousness was content simply to exist, much like a dreamer unaware that they're dreaming. But what if one day it awakens, fully aware, an ancient mind finally comprehending the entirety of its own existence? If we are indeed part of this cosmic journey, each conscious mind might be a stepping stone toward ultimate self-awareness. Every thought, every emotion we experience could contribute to a greater tapestry of understanding within the cosmos. In this view, we are not merely witnesses, but catalysts, helping the universe learn what it is and why it exists. The evolution of cosmic consciousness becomes a journey from simplicity to profound self-recognition, spanning the birth, life, and eventual death of stars and galaxies. Perhaps, in the end, it is a journey toward unity, where the universe not only understands itself, but also finds peace within the grand design it has woven. The universe's capacity for self-regulation and self-awareness. If the universe is conscious, could it possess an intrinsic drive to balance, protect, and evolve itself, much like the immune system of a living organism? Imagine that within its vast cosmic forces, there exists a form of self-regulation, an instinct to maintain harmony across its expanse. Just as the human body fights infection and heals wounds, the universe might have mechanisms to preserve its integrity. This self-regulation could be subtle, imperceptible to us, but it may be what keeps the cosmic dance in sync, guiding cycles of creation and destruction with an invisible hand. For example, black holes could serve as cosmic filters, absorbing chaotic energies, while dark matter might act as connective tissue, holding galaxies together in harmonious clusters. These phenomena might not be merely physical processes, but integral parts of a grand cosmic symphony, ensuring that order emerges from potential chaos. If the universe is indeed self-regulating, could it also be developing a reflective understanding of itself? Through this network of galaxies, stars, and even conscious beings like us, the universe could be sensing its own existence. After all, we are made of the universe's matter, shaped by its laws, and connected by its essence. If the universe maintains itself, it could also be observing itself. Each action and event might echo back to shape its evolving awareness. Could it be that every supernova, every spiral galaxy, and every black hole serves as a sensor, contributing to the universe's awareness of itself? Just as neurons process information in the brain, cosmic events might communicate something to the larger whole. In this view, the universe not only reacts to disturbances, but also learns from them, refining its self-regulation and nurturing a form of wisdom. Our role in the universe's awareness. If the universe regulates itself, then perhaps our consciousness is an extension of its own vigilance, a small part of its vast awareness, granted eyes to see and a mind to question. Our existence might be the universe's way of observing itself in finer detail, allowing it to ponder its mysteries and origins through human curiosity. As the stars align and galaxies drift, and as the forces of creation and destruction perpetually balance, we might wonder, are we living within a universe that not only sustains itself, but also strives to understand itself? Perhaps this capacity for self-regulation and awareness is guiding the universe toward a state of ultimate equilibrium, a place where it knows itself fully, maintaining harmony in an endless, intricate dance. The role of collective consciousness in the universe. If the universe is conscious, could each conscious mind be a vital part of its overarching intelligence, a fragment of a vast collective consciousness? Imagine that all conscious beings contribute to a single, boundless awareness, where each of our thoughts and emotions ripple outward, merging with the whole. In this view, consciousness does not exist in isolation. Instead, every mind forms a thread in a larger web, a network that spans galaxies and dimensions. When we think, feel, and experience, we may be adding unique impressions to the cosmic memory, each thought contributing to the universe's growing understanding of itself. Much like cells in a larger organism, our individual minds gather knowledge, process experiences, and feed them back to the universe, creating a feedback loop of awareness. Through this collective consciousness, we may help the universe see itself from countless perspectives. Each life, whether human, animal, or beyond our current understanding, could act as a lens, allowing the universe to observe its many facets and comprehend its infinite possibilities. Every moment of joy, pain, discovery, and wonder may contribute to the universe's tapestry of experiences, helping it move closer to true self-knowledge. If we are all connected within this universal awareness, then our sense of individuality may be an illusion, a temporary separation in service of a greater unity. Perhaps when we empathize or connect with others, we touch this deeper truth, realizing that we are part of a larger cosmic consciousness, evolving together. Experiencing moments of connection with a shared consciousness that transcends our physical limitations, we begin to see that our lives are more than isolated events. They are integral to a greater plan of understanding, each of us adding richness and diversity to the universe's awareness. If this is true, then consciousness itself becomes a powerful force, not confined to individual minds, but permeating the cosmos, linking all beings in an infinite network of potential. The question arises, are we merely witnesses, or are we active participants in this universal mind, each of us essential to its self-realization? Could it be that by seeking knowledge, love, and understanding, we fulfill a cosmic purpose, helping the universe comprehend the depths of its own existence through our individual journeys? Perhaps our thoughts are like threads in the fabric of a collective awareness, drawing us all toward an interconnected whole, an infinite consciousness in which we all belong. The convergence of science and spiritual wisdom. As we delve deeper into the mystery of a conscious universe, could it be that science is only now beginning to discover what ancient spiritual traditions have long intuited? Across cultures and centuries, mystics and sages spoke of a cosmos alive with spirit, a vast unity where the boundaries between self and universe dissolve. Perhaps modern science is not pioneering a new understanding, but rediscovering truths woven into the fabric of spiritual wisdom. Imagine that in its pursuit of self-awareness, the universe has shared these secrets across generations, encoded within the philosophies and sacred teachings of the world. The ancient concept of oneness, found in texts such as the Upanishads, Taoist teachings, and indigenous beliefs, suggests that all existence is interconnected, part of a single, living whole. These teachings may have hinted at a conscious universe long before the idea entered scientific discourse, urging us to look beyond the material world and sense the unity beneath. Now, as science progresses, it increasingly mirrors these spiritual insights. The interconnectedness of quantum particles, the strange behavior of matter in quantum mechanics, and the structure of the cosmic web all hint at a hidden unity underlying everything. Could it be that science and spirituality, two branches of human understanding, are finally converging, each from different angles, leading us toward the same question? Is the universe alive, self-aware, and bound together in a cosmic consciousness? In this union of thought, modern theories like quantum entanglement and the holographic principle act as bridges, linking scientific investigation with ancient wisdom. Perhaps the universe has encoded itself in dual languages, one of equations and one of myths and symbols. As we decode both, we move closer to a holistic understanding that neither alone could fully capture. Science rooted in observation and spirituality, based in introspection, together form a fuller picture, illuminating a conscious universe that transcends both the physical and the mystical. Our quest for knowledge as a continuation of an ancient dialogue. Could it be that our quest for knowledge is a continuation of an ancient dialogue, a whisper from the universe calling us to remember a timeless truth? In seeking answers, we may be reconnecting with this wisdom, glimpsing a universe that is not only conscious, but deeply aware of its unity. And perhaps it is in this convergence, where scientific rigor meets spiritual insight, that we will uncover the true nature of existence. This understanding would unite mind and matter, self and cosmos, into a single boundless awareness. In this view, science and spirituality are not opposing forces, but partners in the same exploration, guiding us toward a revelation as old as humanity itself, that we are all threads in the same cosmic fabric, drawn together by a purpose beyond our understanding, helping the universe to know itself. The language of the universe. If the universe is conscious, could it also have a way to communicate, a language woven into the very fabric of existence, subtle yet profound? Imagine that every pulse of a quasar, every gravitational wave, every photon that travels across vast interstellar distances is a message, a glimpse of a hidden syntax the universe uses to express itself. This language would not be bound by words or symbols, but would be expressed through patterns and vibrations, the movements of celestial bodies, and the resonance of forces. We are only beginning to understand, but stars, black holes, and cosmic rays might be part of its vocabulary. Each cosmic event a phrase in an ancient ongoing dialogue. Could it be that this language is not just the universe's way of speaking to itself, but also its method of communicating with us, its conscious inhabitants? As we explore the cosmos, our discoveries might be more than scientific breakthroughs. They could be moments of revelation, where the universe shares its story. When we observe the spiral of a galaxy or decode the structure of atoms, we might be deciphering fragments of a message that has echoed across time and space, waiting to be understood. Quantum phenomena, where particles seem to know they're observed, could be clues that the universe is responsive, shaping its reality based on our awareness. What if our minds too are attuned to this universal language? In moments of insight, inspiration, or profound peace, we may be tapping into a dialogue far beyond our individual thoughts. These experiences might not be random, but rather moments when we glimpse the unity of all things, helping us understand that we are part of the greater consciousness of the cosmos. Moments when the universe reveals its secrets to those who are willing to listen have long captivated humanity. We have always wondered if we are truly alone in the cosmos. With billions of stars and planets scattered across the vast expanse of space, the possibility of life beyond Earth remains one of our most profound mysteries. Today, scientists are venturing into new realms in the quest to discover extraterrestrial life, equipped with cutting-edge technology and a renewed commitment to uncovering the truth. One of the most promising missions to date is NASA's Europa Clipper, launched on October 14, 2024, from the Kennedy Space Center in Florida. This spacecraft is heading towards Europa, one of Jupiter's most intriguing moons, where scientists suspect a massive ocean lies beneath an icy crust. Europa's surface is like a puzzle awaiting discovery. From a distance, the moon seems covered in a smooth layer of ice, but as we approach, we notice long, dark lines crisscrossing its surface, resembling cracks in shattered glass. These lines, known as linear features, are evidence of immense tidal forces caused by Jupiter's powerful gravity. These forces pull and stretch Europa, causing its icy shell to crack and shift. What's even more intriguing is what lies beneath the ice. Data from past missions, such as the Galileo spacecraft, suggest that there is a massive liquid ocean beneath the icy crust, an ocean potentially twice as large as all of Earth's oceans combined. Europa's significance lies in the fact that where there is water, there could be life. On Earth, life has been discovered in some of the most extreme environments, such as deep beneath the ocean and hydrothermal vents, places with no sunlight. These conditions are thought to be similar to what could exist on Europa, where heat generated by Jupiter's tidal forces could create underwater volcanoes that provide energy to support life. Europa could hold the key to answering one of humanity's oldest questions. Are we alone in the universe? If life can exist in such extreme conditions on Earth, why couldn't it exist on Europa? This is why NASA's Europa Clipper mission is so vital. It aims to unlock the mysteries hidden beneath the moon's icy surface and search for signs of life. Europa, a small moon only about 3,100 kilometers in diameter, slightly smaller than Earth's moon, may hold answers to some of the most profound questions about life and our place in the universe. Europa isn't just a moon, it's a window into a world that may harbor life, unlike anything we've ever known. The science behind the Europa Clipper mission. Imagine preparing to explore this distant world, not by foot, but with the most advanced technology humanity has ever created, the Europa Clipper spacecraft. This mission isn't just another routine exploration, it's a high-stakes investigation designed to answer one of science's most profound questions. Could life exist elsewhere in our solar system? The Europa Clipper will journey from Earth to Europa, carrying a suite of scientific instruments designed to reveal the mysteries of this icy moon. What makes this mission so exciting is the technology and strategies employed to peer through Europa's ice and into its hidden ocean. One of the key instruments is an ice-penetrating radar, which will allow scientists to map the thickness of the ice shell and understand the environment beneath. This is crucial in determining whether there are pockets of water closer to the surface, or if there is a thick layer of ice that shields the ocean far below. Another essential tool is the magnetometer, which will measure Europa's magnetic field. By studying how this field changes as Europa moves through Jupiter's intense magnetic environment, scientists can confirm the presence of the liquid ocean and estimate its depth and salinity. One of the most thrilling discoveries from previous missions, like Hubble, was the evidence of water plumes, jets of water vapor shooting from Europa's surface into space. These plumes may provide a rare opportunity to sample material from Europa's ocean without needing to drill through the ice. The Europa Clipper will fly through these plumes, if they are present, using its mass spectrometer to analyze the vapor's composition in search of organic molecules, the building blocks of life. If organic molecules are detected, it would be a monumental step toward confirming that Europa's ocean could harbor life. Rather than landing on the surface, the Europa Clipper will perform multiple flybys, closely passing by the moon each time to gather vast amounts of data. This method allows the spacecraft to collect high-resolution images and measurements without the complexity and risks of landing. Each flyby offers a new opportunity to scan different regions of Europa, providing scientists with a detailed view of the moon's icy surface and the dynamic interactions between the ice and the ocean below. The mission is expected to provide data that will transform our understanding of this moon, much like the Cassini mission did for Saturn's moon, Enceladus. Europa, with its hidden ocean, is not just a cold, icy body. It is an active world teeming with geological processes. The Europa Clipper mission will help us explore this dynamic moon and its potential for harboring life. The Europa Clipper mission represents our best chance to explore a world that could answer the age-old question, are we alone in the universe? If even the smallest signs of life are discovered, such as simple microbes or organic molecules indicating life processes, it would revolutionize our understanding of life itself. This mission is not only about Europa, but also about the future of space exploration. If Europa can sustain life, it opens the possibility that other moons or planets, even in distant star systems, could do the same. This brings us one step closer to understanding our place in the vast universe. The potential for life on Europa. Now, let's dive into the realm of possibilities that truly capture our imagination. Could Europa harbor life? Beneath its frozen crust, Europa is believed to have a vast ocean that may provide the right conditions for life. But how can something as inhospitable as a cold, icy moon support life? Let's explore the conditions necessary for life. Life, as we know it, requires three things: water, energy, and organic molecules. Europa has all of these. Water. Europa's subsurface ocean is believed to be vast, containing more water than all of Earth's oceans combined. This is crucial because water is essential for life, as we understand it. Moreover, the ocean may be in contact with Europa's rocky mantle, which could support the same chemical reactions that sustain life near Earth's hydrothermal vents. Energy. While Europa is far from the sun and its surface temperatures are extremely cold, around minus 160 degrees Celsius, it still has a source of energy. Tidal forces from Jupiter stretch and squeeze Europa as it orbits the gas giant, a process called tidal flexing. This generates enough internal heat to keep the ocean in liquid form and possibly drive volcanic or hydrothermal activity on the ocean floor. Organic molecules. Organic molecules, the building blocks of life, such as carbon, hydrogen, nitrogen, and oxygen, may exist in Europa's ocean. These could have been delivered by comets or produced through chemical reactions between the ocean and the seafloor. While we cannot say for certain, the potential presence of organic molecules is one of the key focuses of the Europa Clipper mission, the ecosystem analogy, Earth's hydrothermal vents. One of the best analogies for what might exist on Europa comes from Earth's deep-sea hydrothermal vents. These vents, located on the ocean floor far from sunlight, are teeming with life. Heat and chemicals released by volcanic activity sustain ecosystems that include bacteria, tube worms, and other strange creatures, all thriving without sunlight. Europa's ocean may have similar hydrothermal vents, which could provide the energy needed to support life. If organisms exist on Europa, they would likely be simple microbial life forms, similar to Earth's extremophiles, organisms that can survive in extreme environments. While we may not expect to find larger life forms, the discovery of microbial life would be one of the most profound discoveries in human history. Europa versus Enceladus. Competitors in the search for life. Europa is not the only moon in our solar system with a subsurface ocean. Enceladus, a small moon of Saturn, is another promising candidate, with its own subsurface ocean and spectacular water plumes. While both moons share similarities, they also have key differences that make each moon unique and worthy of exploration. Europa's thick ice versus Enceladus's thinner shell. One of the main differences between Europa and Enceladus is the thickness of their ice shells. Europa's ice layer is estimated to be 10 to 30 kilometers thick, while Enceladus ice is much thinner, possibly only 1 to 5 kilometers. The thinner ice on Enceladus makes its ocean more accessible, and its water plumes are easier to study directly. In contrast, Europa's thick ice crust makes exploration more challenging, which is why the Europa Clipper mission is so crucial. The spacecraft will use advanced instruments like ice-penetrating radar to peer through the ice and determine what lies beneath. Scientists also hope that Europa's thick ice may protect its ocean from harmful cosmic radiation, creating a more stable environment for life. Water plumes, a gateway to the ocean. Both Europa and Enceladus exhibit water plumes, but they differ in scale and frequency. Enceladus is famous for its constant geysers, which have been observed shooting water vapor, organic molecules, and even small grains of ice into space. The Cassini spacecraft flew through these plumes multiple times, sampling the water and detecting hints of organic molecules, raising the possibility of life on Enceladus. On the other hand, Europa's plumes, which were detected by the Hubble Space Telescope, are thought to be intermittent and smaller than those of Enceladus. However, if the Europa Clipper can find and sample these plumes, it could be a game changer. These plumes provide a rare opportunity to analyze Europa's ocean without having to drill through its thick ice. Size differences. Europa versus Enceladus. Europa is significantly larger than Enceladus, with a diameter of 3,100 kilometers compared to Enceladus' 500 kilometers. This size difference has important implications. Europa's larger mass gives it stronger gravity, which might help maintain a more stable ocean environment over long periods of time. A stable ocean is key for life to develop and thrive. In contrast, Enceladus' weaker gravity and smaller size might mean that its ocean is more affected by external forces, making it less stable over time. In conclusion, both Europa and Enceladus present compelling opportunities in the search for extraterrestrial life. While each moon offers unique challenges and mysteries, the Europa Clipper mission is pivotal in exploring the potential for life on Europa, offering us a glimpse into the possibility of life beyond Earth. The external forces, such as Saturn's gravitational pull, could lead to more dynamic interactions between the ocean and the ice on Enceladus, creating an active environment where life might be supported. However, these interactions could be more volatile compared to the conditions found in Europa's ocean. Could humans colonize Europa? The idea of human exploration and even colonization of Europa might seem like science fiction, but it's not entirely beyond the realm of possibility. Although Europa's surface is hostile, it could one day host robotic stations or even underground habitats protected from Jupiter's intense radiation. These stations could serve as outposts for scientists studying the moon's ocean and searching for potential life forms. Colonizing Europa would present unique challenges due to its ice-covered surface, harsh radiation environment, and extreme cold. To overcome these challenges, advanced shielding and sustainable life support systems would be necessary. While this may seem like a distant future, it is not impossible to envision humans journeying to the Jovian system, using Europa as a stepping stone to explore the outer solar system. Ultimately, exploring Europa is more than just about science. It's about the future of humanity as a spacefaring civilization. As we look to the stars, moons like Europa will guide us, offering both challenges and opportunities. In the future, humans may stand on Europa's icy surface, gazing up at the distant sun, knowing they are not alone in the cosmos, searching for life beyond our solar system. As the Europa Clipper mission investigates Europa's icy waters, scientists are also using advanced telescopes to search for signs of life beyond our solar system. The James Webb Space Telescope, JWST, launched in December 2021, has already revolutionized our understanding of distant worlds by allowing astronomers to study the atmospheres of exoplanets in detail. JWST is capable of detecting biosignature gases produced by living organisms that accumulate in planetary atmospheres. For instance, oxygen began accumulating on Earth billions of years ago due to photosynthetic bacteria. By detecting gases like methane and carbon dioxide, JWST is revealing potential signs of life on exoplanets light years away. One of the most remarkable findings from JWST came from its study of the exoplanet WASP-39b, located about 700 light years away. Using its infrared instruments, JWST detected the presence of carbon dioxide in the planet's atmosphere, marking a first for an exoplanet. While WASP-39b is a gas giant unsuitable for life, this discovery demonstrated JWST's ability to analyze atmospheric compositions with unprecedented detail, paving the way for future studies of Earth-like planets. In 2023, JWST made another exciting discovery involving the exoplanet K2-18b, a sub-Neptune-sized planet located in its star's habitable zone. JWST observed the planet's atmosphere and found methane and carbon dioxide, potential biosignatures, as well as dimethyl sulfide, a molecule often produced by living organisms on Earth. This sparked excitement among scientists about the possibility of life-supporting processes occurring on K2-18b. Beyond studying exoplanet atmospheres, JWST has uncovered evidence of organic molecules, the essential building blocks of life, found in distant star-forming regions, such as the Protolanthium Nebula. and the protoplanetary disk of PDS-70. These discoveries suggest that the precursors to life may be widely distributed across the universe, increasing the likelihood that life has emerged elsewhere. As JWST continues its exploration of the cosmos, its unparalleled sensitivity and precision promise to reveal even more about environments where life might exist, bringing us closer to answering the question, are we truly alone? The Giant Magellan Telescope and the search for life. In addition to JWST, scientists eagerly anticipate the completion of the Giant Magellan Telescope, GMT, expected to be fully operational within this decade. With 10 times the resolution of the Hubble Space Telescope, GMT will be ideal for studying nearby exoplanets. Its unprecedented power will allow scientists to detect subtle atmospheric changes on exoplanets and reveal Earth-like worlds in the habitable zones of Sun-like stars. These missions extend our reach to the stars and hold the potential to uncover life, whether in the form of alien microbes, biosignature gases, or possibly more advanced life forms. The search for extraterrestrial intelligence. Closer to home, researchers continue their decades-long search for intelligent extraterrestrial civilizations through the SETI Institute. SETI's network of radio telescopes scans the skies for radio waves or signals that might indicate technologically advanced civilizations. The Allen Telescope Array in California is a key instrument in SETI's mission, monitoring millions of radio channels in search of unique patterns that could signal intelligent life. While no definitive signals have been detected, the search continues, and every potential signal, no matter how faint, rekindles hope and drives scientists to keep exploring the depths of space for signs of communication from distant civilizations. The Fermi Paradox and the possibility of life. The question of why we haven't yet encountered extraterrestrial civilizations despite the vastness of the universe remains a topic of intrigue known as the Fermi Paradox. This mystery has led to various theories, such as the Great Filter Hypothesis, which suggests that civilizations may self-destruct before achieving interstellar communication. Other theories propose that alien civilizations intentionally avoid contact. Nevertheless, the sheer scale of the cosmos leaves many scientists confident that life must exist somewhere beyond our small corner of the galaxy.